Okay, this video is about the ideal gas law. So the ideal gas law says that pressure times volume is equal to the number of moles times a constant called R times temperature. I refer to it as PIV-NERT to help me remember the order of everybody that should be in the equation. So a few things that you need to know about the ideal gas law. Your pressure can be in either atmospheres or kPa, and we'll talk about them in just a second. Volumes need to be in volume needs to be in liters, N needs to be in moles, T needs to be in Kelvin. So there's a very specific constant in the ideal gas law. It's called R, and it's basically a number that helps the math to actually work. So it's just a number that you stick in there depending on which units you're using. So this little guy right here and right here, those guys are just units. It's not a formula or anything, it's just units to help everything cancel out. So the way that you know which R value to use, if your pressure is in kPa, you're going to use 8.31 because this 8.31 has kPa in its units. If you're using ATM though for your pressure, then you're going to be using the 0.0821 because this unit for R has ATM in it. Okay, and then it's just basic algebra. As long as you're in all the right units, it's really not that bad. It's kind of like Boyle's law, honestly. So I'm going to do this one right here. It says, what volume will 2 moles of nitrogen occupy at 96 kilopascals and 20 degrees Celsius? So we are looking for volume. So I'm going to go ahead and I'm going to write out my guess strategy. So the first thing I was given was moles, 2 moles. So I'm going to use N for my moles. Sometimes you'll be given problems where they give you grams of something. And the way that you need to be able to use this for N is you have to do a one-step Stoich problem using the molar mass down here. And you find the molar mass using the periodic table. But in this case, we were given moles straight up, so we don't need to do that little extra step here. So only if you're given grams do you have to divide by the molar mass. All right, next we have a pressure of 96 kilopascals and a temp of 20 degrees Celsius. But because we're in Celsius, we have to get ourselves to Kelvin. So we're going to go ahead and say 293 Kelvin by adding 273 to convert there. We're looking for volume. We have a P, a V, an N, and a T, which means this is the only equation we can use right now, PIV-NERT. And we can decide which R we want to use right here as well. Because we have kPa for our unit of pressure, we need to use that R value because it has kPa in its unit. So I'm going to go ahead and say 8.31. And you're supposed to write out all those little units, but I'm lazy to do that, and I'm sorry. Now you're going to plug and chug for substitute. So we're going to say, okay, 96.0 kPa times times V, right, because we're missing volume, equals 2 moles times my R value times my Kelvin, my temperature. So now that I have that all substituted in, I need to algebraically solve this. So I'm going to divide both sides by whoever the V is partnered with. In this case, that's the pressure. So those guys are going to cancel out, and to make things even, I'm going to go ahead and divide on the other side by the same number. And then I'm going to plug this into my calculator. So I'm going to say 2 times 8.31 times 293 divided by 96. And I end up getting 50.7. And because this is volume, I will use liters. Okay, so once again, I'm just going to tell you a quick things to watch out for. Pressure, you got to get yourself to kPa or atmospheres. Volume, you have to be in liters. If you need help, if you were in milliliters, let's say you had 500 milliliters, you're going to move backwards 1, 2, 3 to get yourself to liters. Okay, temperature, you got to get yourself to Kelvin before you can do anything. If you're given grams, you got to divide by the molar mass to be able to get to moles before you can do anything there as well. And then again, your R values, you choose which one to use based on what your pressure was. Oh no.